Welcome back to The Foundry, brought to you by Forge College. Let's jump right into today's explainer. Testing and validating deployment scripts. This fits right into our broader journey of crafting deployment scripts and getting our apps onto the Solana mainnet. Now, in our last lesson, we literally just finished building our automated deployment tasks. But look, any seasoned engineer is going to tell you, building, that's really only half the battle. Today, we are building the safety net. We're going to test and validate those scripts so they are absolutely bulletproof.
So let me ask you, what actually happens when automation fails? Well, speeding up your deployments without a proper safety net in place, it's kind of like slapping a brick on the gas pedal of a self-driving car that has zero sensors and just aiming it straight at the mainnet. I mean, sure, it's thrilling for about 2 seconds, right? At least until you slam into an unhandled exception, or worse, deploy a completely busted program. We all want that sweet speed of automation, but man, we need the seatbelts of validation for sure. We already hit that first milestone, right? We built the automated tasks to juggle our variables and key pairs. But here's the thing about automation, it's totally a double-edged sword. It magnifies your mistakes. A missing variable or maybe an ignored CLI error, that isn't just going to fail once, it is going to blindly repeat that same exact disaster across every single one of your environments if you don't catch it early. So here is our master blueprint for today's stress tests. We're going to quickly cover the danger zone, building out a test harness, testing for missing credentials, catching CLI failures, running a dry run, and finally, generating a debug report.
All right, part 1, the deployment danger zone.
Before we even think about touching remote state or mainnet, we have to adopt one absolutely crucial concept, and that is fail fast. Failing fast means your script slams on the emergency stop button the exact millisecond something looks sketchy. Operations need to halt right away if there's an insecure or incomplete config. Look, if your script doesn't have a wallet loaded up to pay for a deployment, it shouldn't just shrug and try to execute anyway. No way. It needs to stop, throw a crystal clear error, and alert you instantly.
Moving on to part 2, building your test harness. To actually get that fail-fast behavior, we need a safe local sandbox. We really don't want to accidentally deploy garbage to the real network. So for this setup, we are bringing in Node.js for orchestration, Jest for our assertions, and the solana-test-validator. You'll basically create 3 things. First, a Just assertions file. Second, a wrapper script. This is super important, to normalize output so our tests don't freak out over random whitespace. And third, a fixtures folder for fake key pairs and mock data. Actually, over at Forge College, we constantly hammer home how important it is to build these safe, reproducible, local environments before you ever go live. It's literally the hallmark of a pro developer.
Section 3, the missing credentials test. Okay, now for the fun stuff. We get to break things. Imagine walking up to a high-security bank vault, but you left your ID on your kitchen counter. You shouldn't even make it past the lobby, right? That is our first scenario. The deploy_keypair variable is just totally missing from the environment. Our goal here is to verify that our shell wrapper script does a secure, fast fail. It shouldn't try to guess where your key is, it should just halt immediately. So here is the testing cycle we run. Step 1, we intentionally inject a failure by just dropping that variable completely. Gone. Step 2, we run our jest tests and assert that the script exits with code 2. Which signifies a fatal error in bash. And step 3, we apply the fix. We make sure the script yells a really explicit error message, something like deploy keypair not set, straight to standard error. No mysteries, just a fast, actionable failure.
Next up, section 4, catching CLI failures. So our first test checked for credentials. But what if we actually have them and the Solana CLI engine itself stalls out during the upload? Scenario 2 simulates exactly that by returning a non-zero exit code. A frequent and honestly devastating mistake in automation is swallowing these codes. That's where your wrapper script sees the CLI crash, but happily passes along a success code of 0 anyway. In the world of automation, a silent failure is literally your worst enemy. To stress test this, we are going to tweak our wrapper script to accept a simulate fail flag. We're actively forcing it to mess up. Then, we run our jest test and watch specifically for an exit code 3. To fix the issue, we ensure the wrapper script uses standard bash commands to correctly pass that exact exit code and the error message right back up the chain to the orchestrator. Basically, if the CLI trips up, the whole script needs to fall down, loudly.
Moving on to section 5, the dry run rehearsal. We've tested the catastrophic stuff, but now Think of this as your final fire drill before a real deployment. Scenario 3 introduces the dry run flag. This is an incredibly powerful mode that clearly prints out all its planned actions. It tells you what network it's targeting, what program it's deploying, all without modifying a single byte on the local validator. It's essentially telling you exactly what it would do if you were to let it off the leash. To validate this one, we inject that dry run flag and use jest to assert that the output explicitly contains the text dry run. For the fix, we just ensure the script bypasses the real deployment commands entirely and successfully exits with code 0. It plans, it prints, and it safely exits. Perfect. Finally, Section 6, creating the debug report. All right, so we've run our tests, we've caught our errors, and through all this, we've taken a mysterious automation script and turned it into an observable, super reliable tool. We pulled this off by sticking to 3 core principles. 1, fail fast on bad configurations. 2, normalize your CLI output so your tests can actually read it predictably. And 3, keep your tests completely isolated locally to protect your remote state. Our whole engineering audit wraps up with the debug report markdown file. And look, this isn't just busy work. It is a mandatory audit trail that documents every single failure you injected, the fixes you applied, and the final passing test output from your jest runner. If something breaks 3 months down the line, this report is your absolute baseline. So, with a fully validated, tested, and reliable script in hand, we are totally ready for the next lesson, integrating this into a continuous integration pipeline. But I'll leave you with this thought to chew on. Automation without validation isn't an efficiency upgrade. It is really just a faster way to break your entire application. So is your deployment script a helpful assistant, or is it a loaded gun? Think about it. Keep experimenting, keep validating your code, and make sure to visit us at forge.college to explore more Web3 topics and resources. Thanks for hanging out with the Foundry for today's explainer, and I'll catch you in the next one.